So while we're talking about loops, what I want to do is veer to a topic from the next chapter, and then we're going to come back. And the reason for that is that arrays, which you called lists in Python, and loops go so closely together that I think as soon as you start talking about one, you need to talk about the other. So what is an array? An array is just a list of things, right? It's a series of values. They occupy contiguous parts of the memory so that it's easy for the computer to process them. So if you have a list of numbers, 1, 2, 3, 4, 5, 6, I shouldn't be calling them lists, but that's the term that you used in Python. In languages such as this in Java, a list is a very different thing than an array. Python doesn't have an exact analog for an array. So what an array is, maybe I can Google up a picture of one. It's just a series of values of all the same type. That's one difference between an array and a list in Python. In Python, you can make a list that has, floats and ints and bools and turtles and this and that. In C++, in Java, and all the C-based languages, the array all has to be of the same type. So here is an array of ints, integers. Not really letting me, there we go. This array has a length of 9. How do we know that? Well, I counted, or I cheated. I looked here. But anyways, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 elements in it. If you want to get a hold of the elements of it, you have to use an index. If I want to find out what this array element here, each box is called an element, I would have to use index 0. The next one is index 1. The next one is index 2. So since this is 9 elements long, we can access it via indices 0 through 8. And sometimes that bugs people a little bit. Like if it's 9 long, you ought to be able to access it via array index 9. But if you counted it out, 0, 1, 2, 3, 4, 5, 6, 7, 8, if you put a 9 here, you'd be one past the end of the array. The reason why is that arrays are just like lists, support 0-based indexing. The first element is 0, just like if humans counted from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We have 10 fingers, but if we were going to index in that way with 0, we would count from 0 to 9. 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So whatever the length of the array is, the maximum index you can use is 1 minus the length minus 1. So if you have an array, go back and kind of like that picture. Steal it and put it in Word. We do have volume, yay, alrighty. I need to mention, if I didn't put it in the notes, if I only mentioned it in class, March 15's video, no audio. You don't have to watch it with no audio. It's not even in the list of videos, but you could find it if you went and searched for it. So just upload a note saying, can't watch it. That way you get full credit for it. All right. Get back to this. So this array doesn't have a name according to this. What if this array was called numbers? And I'm going to regret trying to do this in Word rather than Notepad, but let's roll with it. If I want to print this element out, C out, numbers element 0. That would print out 40. And then C out, numbers element 1. What's that going to print out? Yeah, 55. And so on. C out, numbers 8. What's that? That's 89. And then see out numbers 9. No idea. Might crash. Might just return a garbage value. You're reading past the end of the array. Some languages will kick out an error right then and there. You know, Python, if you tried to read past the end of the list, would generate an error right then and there. Same for Java. If you try to read past the end of an array or the end of a list in Java, it'll blow up. It'll give you an exception. The C++, it doesn't check. It doesn't care. It just will blow up. So you have to be very, or it might crash. It might just return the wrong value. Whatever is in memory. Like if each one of these is a byte, or actually an int is 4 bytes, but if each one of these, you know, is 4 bytes, then there's another set of bytes right here, but who knows what data is in that byte? Might be a different array, might be a file name. You have no idea what that is, and then when you try to print out that piece of data, you don't know what it's going to print. There is a category of security problems, of exploits, code exploits, that depend on writing past the end of an array. Because if you can figure out what element number you needed to write to, what index number you needed to write to find some place in the computer's executable code to change the behavior of it, then you could inject some code into the program and make it behave differently, right? So that it would do something completely different than what was expected. And obviously you would have to write that program extremely carefully, but hackers do write their code extremely carefully. So if they find an exploit where your code will let somebody write past the end of the array, it used to be a very common problem when you would declare before strings. The data of a string was held in an array. And you'd say, okay, well, what's the maximum somebody can type in? I'm just going to make up a value. 80 characters. Nobody's going to ever type a first name that's more than 80 characters long. And then they run the program and they feed something that's 8,000 characters, right? So it writes well past the end of the array, you know, maybe finding the part of memory which holds the executable program. A lot of bugs caused by that, by reading strings into an array. Nowadays we use string classes, which are much more bulletproof. You know, they expand based on the amount of data that you're trying to store in it. So this is reading past the end of the array. So the index can be 0 up to length -1. If the array is 100 elements long, you can access elements 0 through 99. Or you can access indexes to get through all 100 elements. You can declare an array like this. You can say, I want an array of ints, and I'm going to give it a name. Every variable has a name, but it's an array. How do I know it's an array? It's got square braces. That's different than it was in Python, where you did something like this, right? You left off this part, and then you use square braces, and you just put values in them, right? That's how you declare the list in Python. Well, that syntax kind of sort of works, but you have to give it a type. You have to give the variable name, and then you tell it, oh, by the way, this variable is an array. And the way you tell that is by using the square braces. If you want, you can put a number inside the square braces, and that says this is an array that's exactly 10 elements long. Or if you want, you can give it a list of values, just like you sometimes did in Python. And this would declare an array that was 4. You didn't have to put the 4 here because the compiler would count. Oh, we gave ourselves an initializer of length 4. You know, the initializers is stuff in the curly braces. And so the first element is a 10, the second element is a 20, the third element is a 30, and the fourth element is a 40. So in this case, the compiler creates an array of size 4, and it puts in those values. Now, if you want to, you can mix both syntaxes. You can say, I want an array that is 4 long, and here I'm going to initialize it. Are you going to do that? Well, you could. If you're going to specify the number of elements, then why put the 4 there? Well, there's a nice syntax. Well, we'll get to that later. Let's play with just creating an array and printing it out. As always, boilerplate, add a new item. It's a CPP file. You don't even need me to read this stuff aloud. All right. The good old boilerplate that we know and love. Now let's declare an array of strings. String names, and let's let ourselves make an array, give ourselves room for 4 names. Now let's copy some names in there. Name subscript 0. I say subscript. That's just an old habit. Some books call it. Name at index 0. I do that because I don't want to say names, open square bracket, 0, close square bracket. But when I say subscript, that's what I mean. Enclose the number in the square braces. Okay, so names, subscript 0 is, well, 0. The first one's going to be Bob. Names, subscript 1 is going to be Sue. Names, subscript 2 is going to equal Tim. And name subscript 3. Can't think of a name alphabetically that's greater than Tim, so Wob, Wobby, whatever. They're in alphabetical order. I should have created something before Sue, right? So it'd become easier to do. Zeb. Yeah, Zeb. That's my 4th name. I don't care what names you use. There we go. We have an array. Now let's print it out. We can use one of our loops. We could use a for loop. We could use a while loop. Let's use a while loop. I'm going to make my counter, my index value, I for index, right? So int I is equal to 0. Why am I starting it at 0? Because, 0. And then while I is less than 4, I could make it, less than or equal to 3, but I have that 4 right there, and I'd like for this code and this code to look as similar as possible. So I'm just going to say while I is less than 4. I'm going to see out names subscript I, followed by ENDL. And I've made the same mistake I always make when I write while loops. What did I do wrong? Why is it printing out Bob a million times? You're right. I forgot to update my loop control variable, I++, or I equals I plus 1. And there we go. It printed out Bob, Sue, Tim, and Zeb. Let's declare another array using that initializer list idea. That's the one where we don't have to specify a value like 4 here. So What's this one going to be? Another array called colors. So string colors, square brackets, and let's just put a couple colors in. We have to enclose the list in curly braces, unlike Python where we use square braces. Python is kind of the oddball. So many languages use this syntax. Red, orange, yellow. That's probably enough. Now we're going to use a for loop. Now this gives us a little bit of a quandary here. And the quandary is that in most languages, I won't say that. In C++, you don't know the length of the array. How long is colors? Well, how do we do it in Python? And don't type this because it doesn't work in here. I would just call it the length, len colors, and it would tell me that it was 3. If I was using Java, I would use colors.length, and it would tell me that it was 3 long. Nope, C++ didn't see fit to do that. So, in this example, we're just going to hard code it. We're just going to put 3. Why don't we declare that as a constant? Const int num underscore colors equals 3. Now, if this looks like a moronic way of doing it, it's because it kind of is. For int I, no, I'm not going to use I because we already have I up here. It'd be okay. It would do that data hiding that I told you about last time where a variable overrides the value of another variable, hides it. But okay, I'm just going to use C or X as my counter. C will do. Int C is equal to 0. C is less than, and then my constant's called num colors. Num underscore colors. C++. Now I'm going to print out cout colors subscript C because that's my index variable. ENDL. Now I don't need to update. I don't need to put C++ down here because that's already part of my for loop. That's the advantage of for loops, is everything's right there in the header. Here I had to initialize, I had my test, and I had my update in 3 different lines. There I have it all in one nice, tidy header. So this is an interesting thing about C++, is you have to keep track of the length of your array. You can't depend on knowing the length of the array. The textbooks will show you a way of calculating the length of the array. It's kind of ugly, but you'll see it. But if you remember, we had a loop in Python which would print through a list, right? For name in names, right? For name in, list variable. Well, you could do that, and somehow magically C++ makes it work, even though it doesn't give us a way of figuring out the length of the list of the array. That looks like this. For every, so for parentheses string s colon colors cout s. Now that looks a lot like what you did in Python. Hopefully y'all did that. Hopefully you did a lot of lists in Python. This is often called the for each syntax. For each string s in colors. Now the C# language actually uses the word for each. Java and C++ don't. They didn't steal that little feature from C#, or at least that naming convention. So that's 3 different ways of printing an array. Well, actually, this way and this way are the same, right? Except one uses a while loop and one uses a for loop. But you can also do that. This is a totally good way of doing it. There's a consequence of doing it this way, though. If I wanted to, I could change the values of the array as we went through. I could say colors subscript C equals silver. If I like silver and I wanted to erase the entire array and fill every element with the word silver, I could do that. Colors subscript C is equal to silver. And that would work because we're directly accessing the memory. But I can't do S equals silver down here because S is a temporary variable that holds the contents of each element in the array in turn. So even if we changed it, it wouldn't change the original array. That may be a benefit and may be a drawback. If you need to change the array, you can't use this syntax, this for each syntax. You have to do something more akin to that. All right, time to stop. And look at files. I think we've talked about for loops enough, in my opinion. I mean, they're incredibly important, but hopefully they're also easy to pick up. So when to use a for loop? In any situation that clearly requires an initialization, a false condition to stop the loop, and an update to occur at the end of each iteration. Now you could do some weird things with for loops that are kind of mangling the intention of it. You know, kind of sticking to the letter of the law, but skirting the way that I think that they ought to be used. And I'll give you an example of that. Don't necessarily type this, but what if we did this? For string data is equal to 0, and then we just didn't do anything else there. And so then we ask for some data. And then we write it back out. Well, first we read it in to a variable named data. I shouldn't have called it string then because I'm reading in something like that. I'm going to change that for int data is equal to 0. So you type a number in, and then I do something with it. I don't know what, you know, do something with it. And then up here, I decide to make it quit if they ever typed in a -1. Okay, that's using a for loop for a completely different purpose, isn't it? That doesn't look like a counting loop at all, but it's legal. We're initializing a loop control variable. We have a condition. We have something that updates it. It's a totally valid thing, but it's weird. So if you leave off a part of the for loop, you know, something between some of the semicolons, it's totally legit syntax. You don't have to have an update here at the end. We could probably. I wonder what would happen if I put this there at the end. I wonder if it will even allow that. Alrighty, I'm going to run this just to see what it does. Yeah, there were build errors. Okay, because I have an extra semicolon there at the end. That's getting hard to read. And if something's hard to read, then it's a sign that something is really bad with the code. But anyways, so if we look at it, I'm going to put each part of the for loop on its own line, each part between the semicolon. That is a totally valid for loop, but it's horrendous and evil. So if you can think of clever things that you want to do with that for loop syntax, welcome to it. And out in the real world, you'll see people use for loops for all sorts of strange things, just because they like the syntax. You know, if we were going to rewrite this, we would put this above a while loop, and then our thing would say while data not equal to 1, and then inside the while loop, we would have that CIN arrow, you know, data. We could write that as a while loop. All right, now that I've demonstrated that, what am I going to do? I'm going to comment it all out. So if you type it in, sorry. But anytime we have code in our daily lectures that asks for input, you know, it just makes running them that much more slow. If you want to write an infinite loop, you could just do this. There. Now we have an infinite loop. Looks like an emoticon, like a crying elephant or something. I don't know. Anyways, so if I run this, don't type this because it's stupid. It just sits there forever. Why is that? it initializes nothing. It has a test condition that's nothing, so it never becomes false. That's kind of weird. And it doesn't do anything when it updates. And inside there, it doesn't do anything. So you can leave off any part of it. You can leave off all three parts. That is the same as writing while true, do nothing, like that. That's another infinite loop. Great. Okay. Get rid of those as well. I did resume the recorder. Good. So the for loop is a pretest loop, just like the while loop. We talked about pretest and post-test, did we not? How the do loop is a post-test? Yay or nay? Okay. You can initialize more than one thing. If you want to, you just separate them with commas. X is equal to 1, Y is equal to 1. It's a weird idea. Maybe let's play with that. Let's tack that on to the end of our program. This one I probably won't comment out because it's not going to ask for input. For int x equals 1, y is equal to 10, semicolon, and we're going to keep running as long as x is less than or equal to 10. And what is our update going to be? We're always going to increment x and decrement y. Now let's see out x followed by maybe a tab to make it look all pretty and stuff. Quote slash t, end quote, arrow, arrow, and then y, and then arrow, arrow, endl. Like that. And so it ought to print a series of numbers 110, 29, 38, 47, and so on. And as predicted, 110, 29, 38, 47, all the way down to 10, 1. Why is it doing that? Well, it's counting two variables. It's keeping track of two variables. We initialized x and y. I only put one thing in the check here because I didn't really think that I needed to check for y as well. But we could have written an expression that had both x and y. And then for our update, we updated both x and y by incrementing x and lowering y. So x counted from 1 to 10, while y counted from 10 to 1. That's just an example that you can stick more than one thing in the initializing statement, and you can stick more than one thing in the update. Writing that would be the same as if we'd written this. Int x equals 1, comma, y is equal to 10, and then while x is less than or equal to 10, see out x, I should have just cut and pasted this stuff, arrow, arrow, slash t, end quote, arrow, arrow, y, arrow, arrow, endl, and then x plus plus, y minus minus. Those two bits of code do the exact same thing. One is obviously much more terse, a shorter way of writing it on the screen. If you like that, go for it. If you think the second one is clearer, go for that. Just be warned that out in the wilds, you'll see a lot of people lean towards doing it in the first way. For no real reason other than the fact that you can fit more code on the page at the same time. Can't think of another reason to do it that way. I think I've said it before, but there's nothing you can do with a while loop that you can't do with a for loop and vice versa. And you can kind of see that here. All right, anybody need more time before I flip back to the PowerPoint? Let me come look. All right, great. Okay, you need to make this less than 4, rather than less than or equal. All right, that's why we're going to comment that. this for loop that had the entering data and then let's type in -1, see if that stops it. No, okay, go ahead and close it. We're going to comment that code out. Yeah, there we go. You can leave it in if you want. You just have to type -1 every time. How's it going? That looks good. Anybody else? You can omit the initialization expression if it's already been done. Just don't put anything before the semicolon. You can omit the update if you're doing it inside the loop. We could take this part out. It's beginning to look a little bit stupid. It's kind of beginning to look a lot more like a while loop, but we could do that. You know, num ++ right there. That is just a valid loop as any other loop, but it's looking a lot more like a while loop at this point. Right? If we just replace the word for with while and then took out a couple of semicolons, yay. Why use a for loop if it looks that much? But you can do that. You can leave off the parts, the initialization and the update if you want. Keeping a running total. This is kind of stuff that you probably did in 1113 in fundamentals. You declare your accumulator variable, total, sum, whatever you want to call it. You initialize it to 0, and then you have a loop, and inside that loop you start adding things to your sum. And then when the condition is met or exceeded, whatever, then it stops adding numbers to it. So this is code that adds a sum of numbers 1 to 10. So it starts our counter off at 1 and it keeps going while that number is less than or equal to 10. If we wanted to add the numbers between 0 and 9,000, we would start num at 0 and we would keep going while it was less than or equal to 9,000. I'm pretty sure we have demonstrated that before. But we could write code that would add the numbers that the user entered. I guess that might be worth doing. Let's do that. So we're going to go here. And it'd be really cool to do this as an array, but I don't want to focus too much on arrays. So here's some code to calculate average temperature. To calculate the average, you need two things. You need a sum and you need a count, right? Because the average is equal to the total divided by the count of the items. So let's declare two variables. A sum, which we will initialize to 0 so that we can add to it, and a count, which I will also initialize to 0. And yeah, I could use a floating point number for the count, but counts tend to be whole numbers because you don't have 1.5 temperatures to add together. You either have one temperature or two temperatures. And then how many months are there? There's 12, but I don't feel like making us type in 12 things each time. So why don't we declare a constant, const int max underscore months equals 3. We're only going to add up 3 months. Now, do we want a for loop or a while loop to do this? Either works just fine. Somebody throw something out, for or while?
While.
Yeah, while. Okay. So while our count is less than max months, and don't type less than or equal to, then let's ask them for the temperature. See out what is the temp for month. Put a space and an end quote, and I'm going to the next line. And you know what? No, I'm not going to mess with that. And an arrow, arrow count, and an arrow, arrow quote, question mark, space, like that. Now I don't have a variable called temperature. I should have declared it before my loop. It's more efficient to declare things outside the loop because otherwise it's got to, declare it each. And what if your loop repeats 20,000 times? Do you want to have it declare a variable 20,000 times, or do you want to just declare it one time up at the top? So I'm going to go and declare it. Yeah, I'll do it right here. Why not? So our temperature is also going to be a floating point so that they can type in that it was 55.3 degrees. Double space temp. That's enough. And then let's let them type into it. CIN arrow temp. And let's add that temperature to our sum. So sum plus temp. That would do it. Or sum equals sum plus temp. Sum equals sum plus temp. And then let's add one to our counter. Count plus plus. Otherwise it'd be an infinite loop. My favorite trick. All right, by the time we're done with that while loop, we have enough information to calculate the average. So let's do that. Double average is equal to the sum divided by the count. And we could print that out. So I think I'll just add C out, average temperature is arrow average. Something like that. C out, average temperature is space, end quote, arrow average, arrow ENDL. If I want to make it pretty, I could use some kind of format specifier to force it to two decimal places and things like that. Where's pause? There we go. All right, we're going to let this run. One thing that the customer is not going to like is because it's asking for month 0 rather than month 1. Okay, so it was 70 degrees in January. It was 40 degrees in February. It was 100 degrees in March, whatever. And so the average of 70, 40, and 100 is 70. Good enough. It's odd that they wound up being whole numbers, but that's just because of the data that I entered. Let's enter something a little bit more creative. 11.5. 23 and 48.123. All right, whatever. Okay, great. I got some floating point digits there. Makes me happier. So this is using a loop to keep track of a running tally. Could have been test scores, bowling scores, temperatures, average weights, average ages, average incomes, any kind of list. And this data could come from anywhere. You could pull it in from a database. You could open up a file and read all that information. You could have the user type it in. It could be a sensor, right? The sensor is being queried every minute, and you're getting the temperature back out of the sensor so that you can calculate the average temperature for the day. That kind of thing. All right. Anybody got syntax errors that they want help with? Nobody? All righty. So that's called a running total. That's the accumulated sum. The simplest one is just to write something that adds up all the numbers in sequence, 1 to 10, something like that. Here we did a little bit more complicated, but not really. We just asked the user to give us the numbers to add. All right, Sentinels. Seems like we've talked about Sentinels a lot, although that may be because I'm also teaching a whole bunch of fundamentals classes. The Sentinel is a value in the list that indicates the end of the data. So enter a test score or negative 999 to quit. Hopefully your teacher isn't such a jerk that he'd give you a negative 999 for a test score. So you could use that as a Sentinel value. A Sentinel value, it has to be one that cannot be confused with a valid value. 0 would be a bad Sentinel value because somebody might really make a 0 on the exam. -1 or -999 is just fine because, you know, hopefully nobody's going to make that grade. And you do that if you don't know how many values will be entered. In this code here, we knew how many values were going to be entered, 3. Or if we wanted to make it a whole year's worth, we would change that 3 to a 12. I just didn't want to make us type 12 numbers in every time we ran it. Oh, I went back and mentioned that I didn't like it saying month 0, 1, and 2. Let's fix that before we're done with this. I'm going to come here to this line where it says arrow, arrow, count, arrow, arrow, question mark, and I'm going to say count plus 1. Right, so instead of printing out 0, 1, 2, it'll print 1, 2, and 3. All right, and it says temperature for month 1, temperature for month 2, temperature for month 3. All well and good. Could we have arranged this code so that we didn't have to add 1 to it?
Yes.
Yeah, probably. We would want to update count at the beginning rather than at the end. That's not a bad change to make. Why don't we do that? Rather than being tacky and putting that plus 1 there, I'm going to delete that plus 1 and then move this to the top of the while loop. See what I'm doing? I'm taking count plus plus, I'm nuking it, and I'm pasting it there. Now it'll print out 1, 2, and 3 rather than 0, 1, and 2. Much better. What would be better still is if we stored the months in an array, so we could say what is the temperature for January, what is the temperature for February, what is the temperature for March. And once we get back to talking about arrays in the next chapter, we'll do that. So use a Sentinel value when you don't know how many numbers are going to be. We could rewrite that loop so that instead of going out to, you know, while the count is less than 3, we could instead check to see what the last data value entered was. And I suppose we may as well do that just because it's a good idea to have the distinction in our mind. I almost don't want to do it. I'm lazy. But alrighty, so we're going to need to reinitialize everything, right? We're going to need to set sum back to 0, count back to 0. Let's do that. So down here, sum is back equal to 0, the count, semicolon, sum equals 0, semicolon, count is equal to 0, semicolon. And then we need to declare a temperature variable outside of the loop so it can be our loop control variable. Double temperature is equal to 0. And what's our Sentinel value going to be? -1? That's not a good one because the temperature really could be -1, right? How about -999? Yeah, that sounds good. Okay, so while the temperature is not equal to -999, let's ask the user for that temperature. First, let's increment count, count plus plus. At this point, we could just copy all this stuff. I'm not sure of that, though. Okay, so arrow, arrow, cout, arrow, arrow, temperature, space, end quote, arrow, arrow, count, arrow, arrow, beginning quote, question mark, space. And then let's let them type that into the temperature. CIN, arrow, arrow, into the temperature. Now we don't want to add that to our sum if the temperature is equal to -999. So I'm going to throw in an extra if statement. The books get around this by having a priming read. So if the temperature is not equal to -9, and I didn't tell them that they could type in -999 to quit. I should throw in a cout that tells them now. But if temperature is not equal to -999, then we want to add to the sum. And I've kind of made a mistake here in my logic. We should only increment the count if it's valid data. We're going to wind up moving that count plus plus down into this temperature if statement. So highlight that. Count plus plus needs to go. Bye-bye, and it needs to be put there. And then we need to add that temperature to our total. Total, or I called it sum, sorry. Sum plus equals temp. Now we have the problem where it's saying temperature 0, temperature 1, temperature 2, rather than 1, 2, 3, 4, 5. But I'm not going to fix that. But we do need to tell them to type in -999 or else they're not going to know how to quit. So let's put a cout statement to that effect. Maybe right up here. Cout, you can enter -999 to stop /n, \n. That's the same kind of thing, except it's using a Sentinel value. Right? It just keeps looping as long as the temperature is not equal to -999. The other one looked a little bit cleaner because using Sentinel values require you to do one of two things. One is to do a priming read up above, or the other is using an if statement in here to rule out if they've typed in bad data and it's finally time to stop. You have to have good data before you can add it to the temperature. If we added -999 to our total, to our sum, be bad, be stupid. All right, and then the last thing we want to do is we want to calculate the average temperature again, right? Let's just do that. Cout, this time the average temp is, end quote, arrow, arrow, sum divided by count, arrow, arrow, space degrees. Just make it look a little bit different. And this will be the last thing we do to it today, so I'm going to make a Dropbox in a minute. Firstly, I want to make sure it runs on my screen. All right, what is the temp for month 1? I'm going to type in 3 numbers. You can enter -999 to stop. Okay, I'm going to enter some numbers, just go hog wild. But eventually I'm going to get tired and type in -999. Okay, so that's working. 2 loops. This is a counter-based loop. And this is a Sentinel value loop. Both of them illustrate using sums. What did the textbook call that? I sure will. I didn't mean to hide it. Yes, I did. Running total. So I'm going to add a comment up here. Calculate average temperature using a running total and a counter loop. And then I'm going to scroll down to the other one where we do the -999 bit, and I'm going to say running total with a Sentinel value. And there we go. Now that doesn't show the print statement. Let me zoom out. See if I can get the whole thing on one screen. All right. That's it. Let me do walkabout, make sure everybody's got it going on.